Now in this video, we'll be going through Chapter 11, Part 2 on linear graphs. We'll be referring to our textbook 1B page 87 for Activity 2, question 1 to 5 to get a better understanding. So in our textbook, Activity 2, here we have the concept of a function. So in this example, the objective is to understand the concept of a function and show the different representations of a function. So in a machine, for example, when you go to a vending machine, you put in money, you put in coins, and the output will be a drink, for example. In another vending machine, perhaps, you put in, again, you put in coins, and it returns you orange juice. So the input in those vending machines will be our money, the output will be a canned drink or an orange juice. So depending on the different machine, we will have different inputs and different outputs. This concept can be represented in mathematics also. In this case, in this example, our input is 2, the output will be 5. Another input of 3 gives an output of 7, so on and so forth. So there is a rule over here which is hidden from us that we have to try and guess. We notice that if you put in a 2, the output is bigger. It's almost double. You put in a 4, you almost double it. Put in a 6, you almost double it. So with this hint, you probably can tell that the output is actually 2 times of the input, and we add 1 to it. So in question 1, when x equals to 2, we notice that the y value, the output, is actually 5, and 5 can be expressed as 2 times 2 plus 1. You notice that it is the same, it is repeated for all the other numbers. When x equals to 5, we multiply by 2, we get 10, we add 1, we get 11. So there appears to be some link between the input and the output. So in words, this is the description of the function. We double the input and we add 1 to get the output. In part 2, question 2, we can represent the function using a table. So the output, as such, instead of using arrows, we put it in a table form. In question 3, if we let x be the value of an input and y be the value of the corresponding output, then x and y will be an ordered pair, and we have covered the idea of ordered pair in the previous set of notes. So form the ordered pair for the values of input and output. So x being the input, y being the output, we have 1, 2, 3, 4, 5 pairs of coordinates. So in part B, plot them in the coordinate plane. So as such, when x equals to 2, y is equals to 5. When x equals to 3, y equals to 7, so on and so forth. And in part C, do they lie on a straight line on the coordinate plane? And quite clearly, if we join them up, they do. Suggest an equation to show the relationship between the input and output. So earlier in words, we said that the output is double of the input and we add 1 to it. So putting that into mathematical terms, we have y equals to 2x plus 1. The final question, 5. Besides the input values of 2, 3, 4, 5, 6, can you suggest other inputs? So definitely we can. Then we need to find out the corresponding outputs. So this is an open question. So example, when x equals to 1, y will be equal to 3. When x equals to 0, y will be equal to 1. We can obtain these information either through calculation or we can get them from the graph. So how many different values of y will correspond to each value of x? In this case, we only have one value of y corresponding to each value of x. So given a certain input, you will get a unique output. You will not have 2 values of y for 1 value of x. So to carry on, a linear function y of x is a function in the form y equals to mx plus c. And in this case, the value of m and the value of c, they are constants. The only variables will be our y and our x. So recall earlier this year, we also talked about variables. X will usually be a variable, y will usually be a variable. So the graph of a linear function, so as long as it looks like this, where there is no x squared or x cubed, it will be considered linear in this case. So from the word linear, the shape of the linear graph is a straight line. So any point AB, where A is the x coordinate, B is the y coordinate, on the linear graph will satisfy the equation. That is, if we have an equation y equals to mx plus c, I put in the a value. Take note that this is the x value. If I substitute the x with a and I substitute the y with a b, the left hand side will be equal to the right hand side. Conversely, that means if we were to reverse the argument, if we see that a and b satisfies the equation, then AB must lie on the linear graph. So here we have a function y equals to 3x plus 1. We have to complete this table. So in the first case, when x is equal to -1, we have y value to be -2. So how I like to do this is by writing y equals to 3, put a bracket, plus 1. I know that this is supposed to be x. So instead of writing x now, we put in -1 for the very first value of x. So we see 3 times of -1 plus 1, 3 times of -1 plus 1, and the value is -2. So remove that for the second x value. So y equals to 3 times of 0 plus 1, which is simply 1. The final x value, y equals to 3 times of 1 plus 1. So we get 4. Now the ordered pair, the x term, the x coordinate must always come first. So -1 comes first. Open the bracket, open all the bracket, put on a comma. The x term, the x value must come first. So we have 0, comma, something. X value must come first, so 1, comma, something. The y value, corresponding y value is 1 in this case. Corresponding y value is 4. So based on this, we can plot the ordered pairs on the table. This x value is -1, so look out for x value of -1 over here. It has a y value of -2. That is my first set of coordinates. Next, when x is 0, y equals to 1, found here. When x equals to 1, y equals to 4. So here we have a straight line. Take note that you need to include the labels for axis. Okay, the vertical axis will be our y-axis, the horizontal label axis will be our x-axis. So join it with a straight line with a ruler, these 3 points. The shape of the graph, it is a straight line. And after you have drawn the graph, answer part D by yourself.